guys, welcome to Triple Act Up. Today we are going to look at another wonderful question in which we'll be able to solve it together. And before we continue, please, if you've enjoyed our videos so far, please don't forget to subscribe to this channel. Also like our page at Triple Act Up. Also don't forget to turn on the notification button so that when a new video is being uploaded, you will not just the video will not just pass you by. And also don't forget to share. All right, tell your friends to tell their friends, also to tell their friends. Thank you. All right, so today we want to look at this wonderful question we have here, and the question is the first three terms of a GP are k minus 1, 2k minus 1, and 7k minus 1. Then what are the values of k? Alright, so for us to do this, first of all, we need to know some things here. The GP we have there, we call it geometric progression. We call it what? Geometric progression. Okay, that's what it means. We also have the other one which we call the arithmetic progression. That one too, we have it there. So but for today we are going to solve this question dealing with what? Geometric progression. And there are some terms in which you need to know that relates to this geometric progression. And what are the terms? The terms are, we have what we call the first term, and the symbol is what? Is A. Then we have what we call common ratio, and the symbol is what? Is R. Then we have some other ones like what we mean when we say nth term of a what? Of a nth term of a geometric progression. And we have some other fantastic term, like, well, since we have the first term, which is the first value of a geometric progression, we also have the second term, we have the third term, and if you want to do that, this n term will be what? AR raised to power what? N minus 1. So that's how you get each of those terms. Just putting the n represent what? The how would I put it now? The consecutive values you want to deal with. If you are looking for the second term, the n represents the 2, which is the second 2. So just put the value of n here, the value of n, which is 2, subtract the power and anything you get, and given the values of the common ratio and the first term, then you get what? You get the nth term. That's just like a brief introduction into what we want to do here. So, and that is what we'll be making use here now. And they said the first three terms of a GP. Okay, so let's see how this goes. Let's see how it goes. Now, the first three terms, which are what? K minus 1, 2k minus 1, and 7k minus 1. So what that means is that what? K minus 1 is the first term, 2k minus 1 is the second term, then 7k minus 1 is the third term. So what do? We write out all this. So our first term, which is A, is equal to what? K minus 1. K minus 1. The second term, which is AR. You might be wondering, how did I arrive at this AR? It is from here. This is second term. Just like what I've just said before, when you are talking about second term, using this formula, n is what? Is the second, which is 2. So it will be what? 2 minus 1. So this will be giving us what? AR. That's 2 minus 1, which is 1. So this is the what? This is the second term. And they say the second term is what? 2k minus 1. the third term, I hope you, the third term. So what do you think the third term will be? Huh? What do you think the third term will be? I know you should be able to tell me how to write the third term using this same formula and what the example I've given. Okay, so the third term will be what? Will be a r raised to power what? 2. So the fourth term will be what? Will be in that form, which is what? A r raised to power 3. Fifth term, and so on and so forth. So the third term is what? Is 7k minus 1. Okay, so we've written out these terms that we are given. This is how they come into play. Now, in geometric progression, where we'll be taking a very important term here, and that is what? That is the common ratio. And when you are talking about the common ratio, we are going to be looking at a kind of a division between what? The third term and the second term. Then you take what? The second term and what? Divide it with what? With the third term. That will give you a ratio. A ratio, and this is how it will come into play. So it's just like saying you are having what? What you're making use of is the AR squared. So you are having AR squared divided by what? The second term, which is what? AR equal to, so what's the value of AR squared, which is this 7k minus 1 over AR. What is AR? Which is what? 2k minus 1. Are we together? Okay, so since this is what we have here, so we divide this. A we what? We divide A. So here, what do we have here? So if r will cancel one of the r here, so it means here the common ratio r is equal to what? 7k minus 1 over what? 2k minus 1. That's what? That's the common ratio for between what? The third term and the second term. So let's look at what the common ratio will be for the second term and the first term. So if you have enjoyed this lecture up to this level, please and please don't forget to subscribe to our channel. Also like our page at Triple Act Hub. At Triple Act Hub. Okay, that's TROIPPLEACT That's it, at Triple Act Hub. Okay, so we've gotten the value for what? The common ratio for the third between the third term and the second term. So let's look at what you get for the common ratio for second term and the third term. So we pick the second term. What do we have there? Which will be what? AR, and the value is what? 2k minus 1. Then divided by what? The first term, which is what? A, and over what? K minus 1. So what do we do here now? So A, we divide what? A. So here the common ratio between second term and first term is what? 2k minus 1 over what? K minus 1. So as you can see, the common ratio for this is what we have here. Then the common ratio for the second and first term, this is what we have here. Now since the common ratio are the same, are equal, since the common ratio are equal, we will now equate. We can now simply say that what? The r equals to what? R, because if we are supposed to be having just one common ratio. So the common ratio of this first one, which let's say maybe we can call it the 1, and the common ratio of what? This, which is what? 2. So we equate them together, and when we do that, we'll be having what? 7k minus 1 over what? 2k minus 1 equal to, then we take this 2k minus 1 over what k minus 1. Okay, so this is what we have after equating the two common ratios. Okay, so the next thing is for us to what? Do a cross multiplication. We do a cross multiplication, that we use the numerator here to multiply the denominator here, then we use the numerator here to multiply the denominator. So what will this give us? We'll be having 7k minus 1 bracket k minus 1 close the bracket equal to 2k minus 1 close the open the bracket 2k minus 1. So let's expand this. So when we expand this expansion of bracket, we use what is inside this bracket to multiply what is inside this bracket. So let's do that. So one after the other. Are we together? So 7k multiplied with k, that will be giving us 7k squared. 7k times minus 1, that will be giving us minus 7k. Okay, so which means we've used 7k to multiply what is inside this bracket. So the next thing is for us to use this minus 1 to multiply what is inside this bracket. So minus 1 times k, that will be giving us minus k. Then here minus times minus, that's plus 1 times 1, 1. Then equal to, let's see what this will give us. Let's use what is inside this bracket to multiply what is inside this bracket. So one after the other. 2k times 2k, that will be giving us 4k squared. Then 2k times minus 1, that will be giving us minus 2k. Alright, so we've used this to multiply everything here. Let's now use this minus 1 to multiply what we have here. So minus 1 times 2k, that will be giving us minus 2k. Okay, minus times minus, that will be giving us plus 1 times 1, that will be 1. Okay, so for this, on the left hand side of the equal sign, let's simplify it further. So we are going to be having 7k squared. So here will be what? Minus 7k minus k, that will be giving us what? Minus 8k. Then here will be what? Plus 1. Okay, equal to, here will be what? 4k squared minus 2k minus 2k, that will be minus 4k plus 1. Okay, so we have this here, we have this. So what do? The next thing is for us to what? Looking at it, they look alike. So what are we going to do? Let's take everything on this right hand side of the equal sign, let's take it to the what? To the left hand side. And what? And do a kind of a collecting of what? Like terms. Are we together? Collecting of what? Like terms. And if you have any issue with what we've done here, the comment section is right there. Ask your question and I will be glad to what? To answer you. Okay, so what we will do is what? Here we're having 7k squared, here we're having 4k squared. They are the k squared, as bring them together. So let's transfer everything on this right hand side of the equal sign. Let's take everything to the what? To the left hand side. So here we'll be having 7k squared. So this is plus 4k squared. When it crosses the equal sign, we'll be having it to go for minus 4k squared. Okay, then here on the we already have minus 8k here. Okay, so here when it crosses, it will be what? Plus 4k. Okay, here we are having plus 1. Then when this crosses, we are going to be having it to be what? Minus 1. So equal to 0. Okay, all right, so let's subtract 7k squared minus 4k. So this will be giving us 3k squared minus 8k plus 4k, that will be giving us minus 4k squared. Oh, sorry, minus 4k plus 1 minus 1 is 0. So that one is gone, so everything equal to 0. Okay, now if you look at this almost look like is also is a quadratic equation. It's a quadratic equation, but the only thing missing out there is what is the constant. Is the constant, which is 0, and we don't need it. Is the constant, but we'll still use what make use of our knowledge in what we've done in the previous class of a quadratic equation. So taking a look at this, what's common? If you look at it, what's common there? K is common, so we have K, open a bracket. What will you be left with? We've left what, 3K minus what, minus 4, all equal to 0. So if after you've done, you get here, then it's for us to split it up. How do we do that? How do we split it up? So let me quickly rub this off. Let's say how we split it up. So taking a look at this, here we are having K, so that means it will mean that what, K equal to 0, or what, 3K minus 4 equal to 0. So here K is already 0, so we have to work with this. So here we'll be having 3K equal to what, 0. This is minus 4. When it comes here, it will be what, plus 4. So here will be 3K equals to 4. So K, we want to get the K, so divide both sides by what, by 3. So K will be equals to what, 4 over 3. Okay, so what does this mean? So the values for K, we said we should look for the values of what, the values of K. So looking at what we have here, the first one is K equals to 0, and the other one is what, is 4 over 3. But here our K, we in geometry, looking at what we have here, the K cannot be cannot be, so we might not make use of this K, but we will make use of what, this K. So this will be our what, our final answer in what, as the value of what, as the value of K. So that's it. So we've come to the end of what, of this class. So if you have enjoyed this tutorial video, please don't forget to subscribe to my channel. Also, the page, like my page at Triple Act Hub. Also, don't forget to inform your friends that is a class, an online class that is going on. So ask your question in the comment section, and will be glad to answer it for you. So have a wonderful day ahead, and bye bye.